Welcome to clickmeproject.com. Let me discuss about the process evaluation of color spatio-temporal interest points for human action recognition. Let me discuss about the process evaluation of color spatio-temporal interest points for human action recognition. Human activities can be categorized into human actions, human-human interactions, human-object interactions, and group activities. Discussing approaches designed for their recognition. The recognition of actions in the video is useful in computer vision. They will be helpful to develop a system that can recognize the actions in the surroundings. Its main applications include surveillance systems, patient monitoring systems, and a variety of systems that involve human interactions with electronic devices and such as human computer interfaces. Most of the applications require recognition of the high level activities, often composed of multiple simple actions of the persons. The videos containing the actions performed by the persons were taken, then they were converted into frames and they pre-processed. The pre-processing is done by using median filter. Median filter finds the noises in the frames and replaces it by calculating the median of the neighboring pixels. Features were extracted from the frames. Extracted features will be useful to recognize the actions of the person. Here we are extracting hair speed, Gable speed, and Hishoji speed. So these are all the feature extraction algorithms. Based on the extracted features, the actions of the persons in the video is recognized by using a BF kernel, which is a function of a support vector machine classifier. The support vector machine trains the feature values based on the kernel functions and arranging the values on the hyperplanes based on the labels of the classifier. The classifier gives the label corresponding to the input feature, that is the input video. The action is recognized based on the label returned by the classifier. The performance of the proposed method is measured by measuring the performance of the classifier. The accuracy, sensitivity, and specificity of the classifier is most commonly measured performance measure. The accuracy represents the reliability, that is how much we can trust the result of the classifier. The specificity and sensitivity of the classifier represents how the classifier categorizes the features to each category correctly and how the classifier rejects the features that are not belonging to the particular category correctly. Let me see the flow of the process. First, the test video is taken and the video is converted into frames. Then pre-processing is applied. So for pre-processing, median filter has been used. Then the process moves on to the feature extraction process. So in feature extraction, first hair step features were extracted. So the algorithm tests each pixels in the image to see if a corner is present by considering the differential of the corner score with respect to the direction. The similarity is measured by taking the sum of square distances between two patches. A lower number indicates more similarity. If the pixel is in the region of uniform intensity, then the nearby edges will look similar. If the pixels is on the edge, then the nearby pixels in the direction perpendicular to the edge will look quite different, but nearby pixels in the direction parallel to the edge will result only in small change. If the pixels is on the feature with variations in another direction, then none of the nearby pixels will look similar. Then after that, Gable strip features were extracted. So the Gable function provides a local spectral energy density concentrated around the given position and the frequency in a certain direction. The two-dimensional convolution with a circular Gable function is separable to a series of one-dimensional ones. The convolution is in two different perpendicular directions is performed with variously dilated wavelets. It is necessary to use a wavelet which serves as a first-order partial differential operator. A Gable wavelet which serves as a second-order partial differential operator can be used to detect the corners. Then we are extracting the hawk step features. The image is divided into small connected regions called cells, and for each cell compiling histogram of gradient directions or edge orientations for the pixels within the cell. The combination of these histograms then represents the descriptor For improved accuracy, the local histograms can be contrast normalized by calculating the measure of the intensity across a large region of the image called the block, and then using this value to normalize all the cells within the block. The normalization results in the better invariance to change the illumination or the shadowing. So based on these features extracted, the same procedure is repeated for all the features which is present for all the videos that is present in the dataset, and the trained features were calculated. The test features, trained features, and the labels were used to recognize the action based on the assume or wave kernel, and the performance of the process is measured. Let me see the execution of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface needed to run the code. This user interface contains all the buttons and controls that is needed to run the code. So first select load video in order to load any one of the videos given here. So here we have described some 8 actions, and videos for those 8 actions were given. So select any one of the video. So here the input video is loading. After the video has been loaded, it will be displayed here. So the video has been loaded and it is converted into frames and it is saved. Then after that we move on to the pre-processing process. So the videos were pre-processed. Then after that we move on to the future extraction process. So here this window will be opened. Click on Harris tip. So the Harris tip points were extracted from the video frames. So they were extracting and the features were saved. So the features were displayed here for this video. So this video contains some 50 frames. So the features for those 50 frames were extracted and it is displayed in this place. Then after that we are extracting Gabor step. So the Gabor step extracts the Gabor points from the object present in the video. So it extracts the corner points related neighboring to the objects. So they will be extracted and the values will be displayed here. Then we move on to HOG step. So the HOG step values were extracted and they were displayed here. So for all the frames the HOG points were extracted. Then we move on to action recognition. So now the action of the proposed input video is recognized as cycling. Then we are measuring the performance of the process. As a performance measure, we are measuring the accuracy, sensitivity and specificity of the classifier that we are using. This bar graph describes the difference in accuracy, sensitivity and specificity between the existing system and the proposed system. So the proposed system values were got by measuring the performance of the classifier that we use, and the existing system values were got by referring to some papers. Then we have drawn the ROC curve for the process. So here it describes the false positive and the true positive rate. So the error rate is much reduced and the distance between them is reduced so much. Then we are describing the confusion matrix. So this confusion matrix describes the error rates in each categories that we have specified. As you can see, the error rates has been much reduced and not so much. Then the proposed system accuracy, sensitivity and specificity were measured here. So if you want to run again, give clear, and if you want to exit, give close. So thus we have analyzed the performance of the proposed system that recognized the action of the input video that we have given. Thank you.